Mohr circle one-on-one. Woo! So this is what Mohr circle looks like itself. But before we actually get into the real circle, we got to talk some terminology. And so stress here in engineering terms is the forces acting upon an object. So it could be compressive forces, which is basically when you push upon the object, or it could be tensile forces, when you're pulling on the object. The next thing you're going to want to know is shear stress. And so shear stress is the forces acting along the object surface. And so it's going to be represented by the Greek letter tau. And stress is going to be represented by the Greek letter sigma. And so sigma is going to be the x-axis, and tau is going to be the y-axis. Now, what is Mohr circle itself? So Mohr circle itself is basically a graphical representation of stress transformations. So we talked about stress being the forces acting upon an object. And so basically you're transforming them, and you're looking at them when you turn the object different angles, what those forces will do at different points on the object. And so it's really, really good for failure testing to see where the object will fail and where it won't. So to start off Mohr circle, you're going to want to find the center of the circle. And so the center of the circle is the average norm stress. And so what you're going to do is you're going to look at your object and the forces acting on it on a two-dimensional plane. So only in the x and the y direction. So you're going to basically cut a slice of your 3D object. And so for the average norm stress, you're going to take the stress in the x direction and the stress in the y direction and add the two together and divide by 2. That'll give you the average stress. And so the center point is the average stress, where your shear stress is 0. So there is no y-axis value. It's just going to be right on the x-axis every single time. Now once you find your center, you're going to want to find your reference point. And your reference point is basically the stress in the x direction and the shear stress in the xy direction. And it's important to note that the shear stress is positive at the bottom, not like it normally is with a regular xy axis. Now once you have your center and your reference point, you're going to want to find your radius. Now you can do this 3 ways. You can build yourself the circle itself here and put the point here and the other point here. And you can just measure the distance. However, keep in mind that's usually just a good estimate. It doesn't give you the actual value. You're going to want to find it using Pythagorean's theorem. So creating a triangle with the center, the reference point, and where the reference point hits on the stress axis. And from there, Pythagorean theorem says you're going to take one side of a right angle triangle, which in our case is going to be the change in stress between the average stress and the reference point and the stress in the x direction from the reference point. And then you're going to square that value, and then you're going to take your shear stress and you're going to square that value. Then you'll square root the entire thing, and that'll give you your radius. Or you can come over here and just plug in all the values from in this equation. So you're going to take your stress in the x direction, stress in the y direction, and your shear stress, and just put it all into one equation and plug it in all together. Now, with that everything said, you're going to have a baseline for your triangle here, and you can just take this radius, drag it all the way around, and you'll have your circle. From there, you can find your maximum and minimum values for like your stress or your shear stress to see where your object's going to break. And with that, you know the basics of Mohr circle.